Hi, I'm Linda from English Learning Mind Map. Today, we will learn about material innovation. Material innovation. To replace synthetics and curb depletion through material innovation, we must rethink our basic ingredients. Basically, we are making new building blocks that don't hurt the planet. Bio-based polymers. As a core pillar of material innovation, bio-based polymers allow us to derive from nature and eventually break down safely. In simple terms, we are making plastic from plants instead of oil. Cellulose reinforcement. Cellulose reinforcement is a branch of bio-based polymers used to stiffen structures and utilize wood pulp efficiently. This means adding tiny bits of wood to make our materials much stronger. Nanofiber integration. Through nanofiber integration, scientists combine particles and weave webs of invisible strength. To put it simply, we are tying the smallest pieces together to make a tough net. Polylactic synthesis. Polylactic synthesis serves as a functional layer of bio-based polymers to create resins and eliminate toxins in the factory. Essentially, we are brewing a natural glue that is safe for people to touch. Corn-starch fermentation. Within polylactic synthesis, corn-starch fermentation is used to sour sugars and brew plastics in a giant tank. In other words, we let plant sugar turn into acid to make the base for our bioplastic. Recycled aggregates. Recycled aggregates is a vital branch of material innovation used to repurpose waste and divert from landfill tons of old debris. Simply put, we are taking trash from old buildings and using it to build new ones. Demolition upcycling. Demolition upcycling is a core part of recycled aggregates where we salvage debris and renew rubble from fallen walls. This means saving the old bricks so we don't have to make new ones from scratch. Concrete crushing. Under the umbrella of demolition upcycling, concrete crushing is used to smash blocks and grind stones into small pieces. To put it simply, a big machine breaks old walls into a powder we can use for new roads. Glass-Cullet Blending. Glass-Cullet Blending is a functional layer of recycled aggregates used to mix fragments and melt shards into a new recipe. In short, we are using old bottles and windows to help make our building materials. Sand substitution. Through sand substitution, builders can replace grit and save beaches from being destroyed for their sand. Effectively, we use crushed glass instead of real sand to protect the natural shorelines. High-performance composites. High-performance composites is a critical requirement for material innovation to optimize weight and boost durability of structures. Effectively, we are mixing the best parts of different materials to make something super strong. Laminated timber. Laminated timber is a strategy within high-performance composites where we glue planks and stack wood to build skyscrapers. This involves sticking many pieces of wood together to make a beam as strong as steel. Cross-layering. By using cross-layering, engineers can turn grains and press layers to make the wood panel very stable. To put it simply, we change the direction of the wood in each layer and squeeze them flat. Fiberglass Alternatives. Fiberglass Alternatives is a technical application of high-performance composites used to swap glass and lower heat during production. In simple terms, we use plants like hemp to replace the itchy glass fibers. Hemp fiber molding. To finish the part, hemp fiber molding is used to shape plants and set glue in a specific form. This means putting wet plant fibers into a tray and letting them dry into a hard, useful shape. Carbon-negative concrete. Carbon-negative concrete is a fundamental goal of material innovation to trap CO2 and offset emissions from heavy industry. Basically, we are making a wall that eats pollution from the air. Biochar infusion. Biochar infusion is a core part of carbon-negative concrete used to mix coal and lock carbon inside the solid block. This means putting charcoal into the mix so the carbon can never escape into the sky. Charcoal sequestration. Through charcoal sequestration, we can bury ash and store smoke inside the very bones of our buildings. In other words, the building becomes a giant box for holding onto the world's bad air. Mineral carbonation. Mineral carbonation is a practical goal of carbon-negative concrete used to turn to stone the gases that cause warming. Essentially, a chemical reaction turns the carbon dioxide into a solid piece of rock. Curing optimization. Under the umbrella of mineral carbonation, curing optimization helps to dry fast and harden walls in record time. To put it simply, we make the chemical reaction happen quickly so the building gets strong and ready to use. Thanks for watching. Please like and subscribe for more English lessons.